Good morning to all. My name is Revati and I am from the Department of Computer Science and Engineering from Srinivasa Ramanujan Institute of Technology. My topic is about the implementation of queues using an array. Introduction to queue. A queue is a linear data structure which follows the first input and first out principle, which is also called as FIFO principle. Elements are added at the rear and removed from the front, maintaining their order. And queues are widely used in various applications such as scheduling and as well as buffering. Characteristics of queue. To implement a queue using an array in a data structure, we must need to initialize an array two pointers, which is front and rear, and then use these pointers to manage enqueue, adding an element to the rear, and dequeue, removing an element from the front. Queues have two main operations: enqueue, which means adding an element, and dequeue, which means removing an element. These they also include operations to check whether the queue is empty or full. The size of the queue can be fixed or dynamic depending upon the implementation. Queue operations. The enqueue operations adds an element at the rear of the queue. The dequeue operations remove the element from the front of the queue. Additional operations may include peeking at the front element without removing it. Array representation of queues. An array can be used to implement a queue by maintaining a fixed size. The front and rear indices are maintained to track the position of the elements. This implementation is simple but has a limitation in terms of fixed capacity. Implementation structure. A queue can be implemented using a fixed size array. Two pointers, front and rear, are used to track the positions of the first and last elements. An integer variable size keeps track of the current number of elements in the queue. Enqueue operation in array. The enqueue operation involves placing the new element into the rear index. After adding the element, the rear index is incremented to point to the next position. Care must be taken to check if the queue is full before adding the element into the queue. Dequeue operation in the array. The dequeue operation involves removing the element at the front index. The front index is then incremented to the point to point to the next element in the line. It is important to check if the queue is empty before attempting to the dequeue. Handling overflow and underflow. Queue underflow occurs when trying to enqueue an element into the full queue. Queue underflow occurs when trying to dequeue from an empty queue. Proper checks should be implemented to handle this scenario and to avoid errors as shown in the figure. Example use case of queues using arrays. Consider a print queue in a printer management system. Documents are added to the queue as they are sent to the printer. The printer processes each document in order, ensuring a fair and organized output. Limitations of array implementation. The main limitation is the fixed size of the array, which may lead to the waste of space. Once the queue reaches its capacity, it cannot accommodate more elements unless it is resized. Additionally, managing the start and end indices can become more complex with large datasets. Conclusion. The array based implementation of a queue is straightforward and efficient for fixed size requirements. While it has limitations such as potential overflow and underflow, it serves many practical applications. Understanding queues is essential and effective for data management and algorithm design. Thank you for giving me this opportunity.